In the vast cosmos, a question lingers. Are we alone? This question has captivated minds for centuries. The universe teems with billions of stars and planets. It seems improbable we are the only intelligent life. Yet we find no evidence of extraterrestrial civilizations. This silence is the crux of the Fermi Paradox. Named after physicist Enrico Fermi, it questions why we haven't found extraterrestrial life. To grasp the Fermi Paradox, one must comprehend the vastness of the universe. Our Sun is one of hundreds of billions of stars in the Milky Way. The Milky Way is one of billions of galaxies in the observable universe. The numbers are almost incomprehensible. Each star could harbor its own planetary system. The conditions for life could have arisen elsewhere. The vast distances pose significant challenges for communication and travel. These distances have profound implications for our search for extraterrestrial life. Given the immense scale of the universe, the question, "Where is everybody?" takes on a haunting significance. This question, posed by Enrico Fermi, encapsulates the essence of the Fermi Paradox. If intelligent life is not unique to Earth, shouldn't we have encountered some sign of it by now? Perhaps extraterrestrial civilizations are rare, or they destroy themselves before achieving interstellar communication. The Fermi Paradox highlights the limitations of our current understanding of the universe and the origins of life. The search for extraterrestrial life continues to inspire scientific inquiry and ignite our imaginations. Where is everybody? This simple question, posed by physicist Enrico Fermi during a casual lunchtime conversation in 1950, has reverberated through the halls of science ever since. It is a question that strikes at the heart of our understanding of the universe and our place within it. Fermi's query was not simply a matter of idle curiosity, it was rooted in a deep understanding of the vastness of the cosmos and the potential for life to exist beyond Earth. Fermi, known for his brilliant mind and ability to simplify complex problems, recognized the seeming paradox between the high probability of extraterrestrial life and the lack of any observable evidence. He reasoned that given the immense age and size of the universe, countless opportunities must have arisen for life to emerge on other planets. If even a tiny fraction of those life forms developed advanced technology, the galaxy should be teeming with evidence of their existence. Yet despite decades of searching the skies for radio signals, scanning distant stars for signs of advanced civilizations, and sending probes to explore our neighboring planets, we have found no definitive proof of extraterrestrial intelligence. This eerie silence, this absence of any cosmic greeting, has become known as the Fermi Paradox, a haunting reminder of our cosmic loneliness. The Fermi Paradox is not a scientific theory in the traditional sense, but rather a profound observation that challenges our assumptions about the universe and our place within it. It is a question that forces us to confront the possibility that we are alone in the vast expanse of the cosmos, a thought both humbling and unsettling. But it also invites us to consider alternative explanations, to explore the boundaries of our understanding of life, intelligence, and the very nature of reality itself. To fully grasp the significance of the Fermi Paradox, one must first attempt to comprehend the sheer scale and grandeur of the universe we inhabit. Our Sun, a seemingly ordinary star amidst billions in the Milky Way galaxy, is but one of hundreds of billions of stars in our galaxy alone. And the Milky Way itself is just one of billions upon billions of galaxies scattered throughout the observable universe, each containing billions or even trillions of stars. The numbers involved are so astronomically large as to defy human comprehension. Even if the conditions required for life to arise are incredibly rare, the sheer number of stars and planetary systems suggests that it is statistically improbable for Earth to be the only planet harboring life. The building blocks of life, such as organic molecules and water, have been detected in interstellar clouds and on other celestial bodies within our own solar system, hinting at the possibility of life emerging in a variety of environments. Moreover, the universe is incredibly ancient, having existed for approximately 13.8 billion years. In contrast, our own planet formed a mere 4.5 billion years ago, and life on Earth emerged relatively soon after, around 3.5 billion years ago. This vast timescale provides ample opportunity for life to have arisen and evolved elsewhere in the universe, potentially reaching levels of intelligence and technological sophistication far beyond our own. Given these factors, it seems almost inconceivable that we are truly alone in the cosmos. The universe appears to be teeming with possibilities, with countless opportunities for life to emerge and flourish. Yet the silence from the stars persists, deepening the mystery of the Fermi Paradox. The lack of any detectable signs of extraterrestrial civilizations is particularly perplexing given the advancements in technology we have made in recent decades. With powerful radio telescopes, we can now listen for faint whispers from distant star systems, hoping to intercept a stray signal that betrays the presence of an alien civilization. We have sent probes equipped with sophisticated instruments to explore our neighboring planets and moons, searching for even the most basic forms of life. Yet, the cosmos remains stubbornly silent. The search for extraterrestrial intelligence, known as SETI, has been ongoing for over half a century, but it has yet to yield any conclusive evidence. While there have been a few tantalizing signals over the years, such as the famous WOW signal detected in 1977, none have been repeated or confirmed as being of extraterrestrial origin. This great silence, as it is sometimes called, has led some scientists to propose that intelligent life is exceedingly rare in the universe. Perhaps the conditions required for life to emerge are far more specific and improbable than we initially thought. It is possible that Earth, with its unique combination of factors such as its distance from the Sun, its magnetic field and its moon, is an anomaly, a cosmic fluke that allowed life to flourish against all odds. This line of thinking suggests that we may be alone in our galaxy, or even in the observable universe. While this possibility is both humbling and somewhat disheartening, it highlights the preciousness of life on Earth and the importance of preserving our planet for future generations. Another possible explanation for the Fermi Paradox is that extraterrestrial civilizations do exist, but they are simply too far away for us to detect with our current technology. The vast distances between stars pose a significant challenge for communication and travel, even for hypothetical advanced civilizations. A civilization on a planet orbiting a star thousands of light-years away would have no way of knowing we exist, and even if they did, it would take thousands of years for their signals to reach us. Furthermore, the universe is not a static entity. Stars and planetary systems are constantly moving and evolving. It is possible that civilizations have risen and fallen throughout cosmic history, their signals long since faded into the background noise of the universe. Just as civilizations on Earth have experienced periods of growth and decline, so too might extraterrestrial civilizations be subject to the ebb and flow of time. The Fermi Paradox, therefore, might not be a reflection of the absence of extraterrestrial life, but rather a consequence of the limitations imposed by time and distance. We may simply be living in a relatively quiet epoch of the universe, a brief moment in cosmic history where intelligent life is sparsely distributed and the means to communicate across interstellar distances remain elusive. The rare Earth hypothesis suggests Earth might be a rare oasis of life in a vast, barren universe. Conditions for complex life are so specific and improbable that they might have occurred only once in the Milky Way. Earth's unique factors include its habitable zone, liquid water, stable orbit, and protective magnetic field. These factors create a stable environment for life to evolve over billions of years. The rare Earth hypothesis argues this cosmic lottery win is so improbable, making Earth truly special.
Thank you.
The Fermi Paradox isn't just about the probability of life, but also the timing and duration of its existence. Even if life is common, the chances of two civilizations existing simultaneously and within communicable distance are slim. Civilizations might rise and fall, their signals fading into the interstellar background long before another emerges to detect them. Imagine a civilization that arose billions of years ago, developed advanced technology, and then succumbed to internal strife or cosmic catastrophe. Their signals would have long since dissipated, leaving no trace for us to detect. We might be looking for signs of extraterrestrial intelligence during a quiet period in the universe's history. Or perhaps we are too early, and intelligent civilizations have yet to emerge in significant numbers. The Fermi Paradox suggests a great filter that prevents life from evolving to interstellar communication or colonization. This filter could represent a critical juncture in evolution that's difficult to overcome. One possibility is that the emergence of life itself is incredibly rare. Another is that the great filter lies along the path from simple organisms to complex, intelligent life. Perhaps intelligent civilizations inevitably develop the means to destroy themselves. This sobering possibility suggests that intelligence might also be our undoing. The great filter highlights the potential fragility of life and the challenges in reaching cosmic significance. We are in a cosmic race to overcome the great filter and secure a future among the stars. The vast distances between stars pose a formidable challenge to interstellar communication and travel. The speed of light, while fast, is agonizingly slow on cosmic scales. Even traveling at light speed, it would take over 4 years to reach Proxima Centauri. Developing spacecraft capable of even a fraction of light speed requires immense energy and innovation. Traditional rockets are inadequate. We need new propulsion systems like fusion drives or antimatter engines. Interstellar space is filled with hazards like gas, dust, and high-energy particles. Advanced shielding or navigation systems are necessary to protect interstellar travelers. The Zoo hypothesis proposes that advanced extraterrestrial civilizations are aware of us, but choose to conceal themselves. They might observe us from afar, like zookeepers studying a new species. This concept raises questions about intelligence, ethics, and our place in the cosmic hierarchy. Advanced civilizations might have a prime directive to refrain from interfering with emerging civilizations. They could be motivated by cosmic preservation or see us as a future resource or trading partner. The idea that we are being watched and studied is both exhilarating and unsettling. The Zoo hypothesis also raises questions about the nature of intelligence and the motivations of advanced civilizations. Are they benevolent or malevolent? These questions fuel our imaginations and inspire us to consider the possibilities of encountering intelligent life. The Fermi Paradox has led some to propose that we might be living in a computer simulation created by advanced intelligence. The simulation hypothesis suggests that future computational power could simulate entire universes. A technologically advanced civilization might create a simulated universe for scientific experiments or entertainment. If we are living in a simulation, it might be impossible to prove or disprove its existence. The laws of physics could be lines of code, and the universe a carefully constructed illusion. This realization could be both liberating and terrifying, questioning the meaning and purpose of our existence. The vast distances between stars pose a challenge to interstellar communication. Signals become increasingly faint and difficult to detect the farther they travel. The inverse square law dictates that signal intensity decreases with distance. Interstellar space is filled with gas, dust, and particles that can absorb and distort signals. The expansion of the universe causes redshift, shifting signals to lower frequencies. A civilization's signal might be undetectable by our current technology. Our radio telescopes might not be sensitive enough, or we might be looking in the wrong frequencies. We may need new technologies or strategies to detect faint or distorted signals. The Fermi Paradox raises the possibility that intelligent civilizations are not long-lived. There might be a fundamental limit to the lifespan of a technological civilization. Technological advancements might carry the seeds of a civilization's destruction. Nuclear weapons, climate change, and other threats could pose existential risks. Internal pressures like political instability and resource scarcity could lead to collapse. History shows civilizations rising and falling under internal contradictions. If civilizations self-destruct before colonizing other star systems, it could explain the lack of detectable signs. This possibility highlights the fragility of civilization and the importance of addressing existential challenges. The Fermi Paradox has fueled the search for extraterrestrial intelligence, or SETI. SETI scientists use sophisticated technologies to listen for signals from distant civilizations. The field draws on expertise from various disciplines, requiring powerful instruments and innovative thinking. One primary tool is the radio telescope, capable of detecting faint radio waves from space. Radio waves are well suited for interstellar communication due to their long wavelengths. SETI researchers scan the skies for narrowband signals, which are easier to distinguish from background noise. Despite the challenges, SETI researchers remain optimistic about the potential discovery of intelligent life. The search for extraterrestrial intelligence is akin to searching for a needle in a cosmic haystack. The Milky Way galaxy alone contains billions of stars, each potentially harboring its own planetary system. To make matters more challenging, we don't know what frequencies alien civilizations might be using for communication, or even if they are using radio waves at all. They might be employing other forms of electromagnetic radiation, such as lasers or neutrinos, or perhaps they are using technologies that we haven't even dreamt of yet. To address this challenge, SETI researchers have developed a variety of search strategies. Some projects, such as the SETI Institute's Project Phoenix, target specific stars that are considered likely candidates for hosting habitable planets. Others, such as the University of California, Berkeley's Serendip project, piggyback on observations being made by other astronomers, analyzing the data for any unusual signals that might have been missed. One promising avenue of research is the search for technosignatures, which are any observable indicators of technology that would betray the presence of an advanced civilization. These could include things like artificial structures in space, such as Dyson spheres, hypothetical megastructures built around stars to harness their energy, or the spectral signatures of industrial pollutants in the atmospheres of exoplanets. Another approach is to search for signs of extraterrestrial intelligence in the vast amounts of data being collected by telescopes and other scientific instruments. This data mining approach utilizes sophisticated algorithms to sift through terabytes of data, looking for patterns or anomalies that might indicate an artificial origin. The search for extraterrestrial intelligence is not limited to radio waves. New possibilities for detecting signs of life beyond Earth are emerging. These new horizons are expanding the scope of SETI. One exciting area is the search for biosignatures. These include gases like oxygen, methane, or ozone. Other biosignatures include complex organic molecules. Exploring our solar system for microbial life is promising. Life may exist closer to home. Mars is a prime target for life search. Europa and Enceladus are promising candidates. New technologies are crucial in this search. Next-generation telescopes will study exoplanet atmospheres. Spacecraft missions are equipped to detect life. The search for extraterrestrial intelligence is a journey into the unknown, driven by curiosity and wonder. The future of SETI is bright, fueled by technological advancements and innovative thinking. Increasing computing power and AI are revolutionizing our search for extraterrestrial signals. AI helps identify patterns and anomalies, optimizing our chances of finding signals. SETI is also about understanding the conditions that give rise to life and intelligence. By studying exoplanets and exploring our solar system, we learn more about ourselves. The search for extraterrestrial intelligence is a profound endeavor, reshaping our understanding of the universe. Whether we are alone or part of a larger cosmic community remains to be seen. The Fermi Paradox, a question that has haunted scientists and philosophers, remains unanswered. Despite the vastness of the universe, the silence from the stars continues. This silence should fuel our curiosity, pushing us to explore more daring possibilities. The search for extraterrestrial intelligence is a testament to our innate curiosity. The universe is a place of astonishing diversity and complexity. The Fermi Paradox reminds us that many surprises undoubtedly await us. The search for extraterrestrial intelligence continues with renewed vigor. Advances in technology, such as powerful radio telescopes and space-based observatories, are opening new avenues for exploration. We can now detect fainter signals and scan wider swaths of the electromagnetic spectrum. The search has expanded beyond traditional radio signals. Scientists explore detecting alien civilizations through environmental impacts. The journey continues, and the possibilities are vast and full of wonder.